So question 7 is an estimation. So you can see that it's 593 over 4.1 times 9.7. So when it says estimate, we're just kind of rounding these numbers up. So you can see that this one is 600. So 593 changes to 600. 4.1 gets estimated to 4 and 9.7 gets estimated to 10. We multiply the denominator, which is 4 times 10, which is 40. We can divide top and bottom by 10 to get rid of those zeros, and what we're left with is 60 divided by 4. When we do 60 divided by 4, it's equal to 15. So question 8 is a ratio question. So like the prize money in a golf tournament is divided between the 3 golfers who finish first, second, third in the ratio 7, 4 and 3. What fraction of the prize money does each of the first 3 golfers receive? Write each fraction in its simplest form. So the first thing we do is we add up 7 plus 4 plus 3 to find out how many parts in total we have here. So we see it's 14 when we add them up, and we just put them over as a fraction. So it's 7 out of the 14, 4 out of the 14, 3 out of the 14. And we get to this stage, then we cancel down. So 7 over 14 will change to a half because we're dividing 7 to both top and bottom of 7 and 14. So with 4 and 14, we divide top and bottom by 2, and we get 2 over 7, and 3 over 14 can't be simplified. So that's the final answer there. So first with the half, second was 2 sevenths, and third was 3 over 14. Question 9 is a transformations question. So it says, describe fully the single transformation which would move shape P onto shape Q. So that's going from shape P to shape Q. You find is its rotation. So to check that out, you would have tracing paper, and you would draw P on the tracing paper and just put your pen on 0, 0, and just try that, and you would spin it around and see if it fits onto this. And it does after 180 degrees, so it's a half a turn. So it's a rotation of 180 degrees about 0, 0, which is where your pen was there. So translate P, shape P by 2 units to the right and 5 units down. So all it is just moving it. So we take shape P and we move it, take each point and move it 2 units to the right and 5 down. And that's the same for every point. 2 units to the right, 5 down. 2 units to the right and 5 down. And we just draw and label it T. So question C is, describe fully the single transformation which would move shape T back to shape P. So basically it's just reversing what we've just done. So it's instead of 2 units to the right, it'll be 2 units left, and instead of 5 down, it was 5 up, so going back to the original position. So question 10 is indices. So we multiply the 4 and the 3 together to make 12, and then we look at our indices, and because there's a multiplication here, we're adding our indices, so it's 3 plus 4, which is 7. So that's the answer, is 12 y to the power of 7. When we've got brackets like this, we're multiplying our indices together, so it's 4 times 5, which is m to the power of 20. So this one's solving an inequality, which is 6y plus 5 is greater than or equal to 2. What we want to get is, it's just like solving an equation. So we have 2 take away 5, which is minus 3. And then we have minus 3 divided by 6. And we have written it there, and then we can cancel it down to minus a half. So the answer there would be y is greater than minus a half. So the next one is B, is write the smallest integer value of y, which satisfies the inequality. 6y plus 5 is greater than or equal to 2. Right, so we've already solved it. So using y is greater than or equal to minus a half, And what I've done here is put a number line down and positioned where minus a half would be. And these here, -2, -1, 0, 1, 2, are all integers, which is asking you for. So the starting position is minus a half, and we're going to the right. So the first integer when you're going to the right is 0. That's the first integer you come to, and that means the answer is 0 on this particular question. Okay, question 12 is a binary question. So it says write 25 as a binary number. So the first thing you do, you set it up by doing 1 on the right hand side and then just keep timesing by 2. 1 times 2 is 2, 2 times 2 is 4, 4 2s are 8, 8 2s are 16. Now the next times 2 is 32, which is too big. So we keep it at 16. So when we look at this one here, we put a 1 at the 16 and we figure out what's left. So there's 9 left after you've taken 16 off of 25, and you'll see that 8 and 1 make 9, and whatever's left is just put zeros in it. So this is your binary number for 25. So it says write the binary number 1101001 in decimal form. So it's exactly the same as what we did before. 1 times 2 is 2, 2 times 2 is 4, 4 2s are 8, 8 2s are 16, 16 times 2 is 32, and 32 times 2 is 64. So we put it above the binary number here. And anywhere you see ones is where we get the values. So you can see 64 has a 1, 32 has a 1, 8 has a 1, and 1 has a 1. So we add these up. 64 plus 32 plus 8 plus 1 is 105. So for question 13, it's changing the subject. So we've got H equals MR plus S. So the first thing that I've done, now you can do this in many different ways. For this one, I have just flipped this equation over. Instead of H equals MR plus S, I've done MR plus S equals H. And then what I've done is I've done H take away S, and then it's H take away S divided by R, and that's what we've got here. And so that's your final answer, H take away S over R. So question 14 says 2 fair dice are rolled. Make a list of all the ways it is possible to get a score of 7 on the 2 dice. So you have to look at it as the first number would be the first dice. So if the first dice come up as 1, the second dice should come up as 6. First dice comes up as 2, the second one should come up as 5. 3 and 4, 4 and 3, 5 and 2, 6 and 1. These are all the possible outcomes you could get from 7 from throwing 2 dice together. So for question 15, it's a graph. It's the simultaneous equations graphically. So if we look at the question, it says, by drawing a suitable line on the grid opposite, solve the simultaneous equations. Y equals 2x minus 2 and y equals minus 3x plus 2. Now in the question, this line here has been drawn for you. Now you have to figure out which one of these equations would be this line. Now you can see that if it's going down this way, it's a negative gradient, and the gradient is always connected to the x here. So you can see that it's minus 3x, that just means it's a negative gradient, but also this line crosses at 2 on the y-axis. So that's another indication of plus 2, which means it crosses the y-axis at 2. So this means that this one has already been drawn for you. So we have to draw this line here. So to go about that, we build up a table of values. So it's minus 2, minus 1, 0, 1, and 2. We get this from the x-axis here. So minus 2, minus 1, 0, 1, and 2. And what we do is we just substitute into the equation. So it's basically, this one is the line that we're looking for. So it's 2x minus 2 what that means is 2 times x minus 2. So these are x values. We take minus 2, and it's 2 times minus 2, which is minus 4. Take away 2 is minus 6. Then we take the minus 1. 2 times minus 1 is minus 2. Take away 2 is minus 4. And we carry on like that. 2 times 0 is 0. Take away 2 is minus 2. 2 times 1 is 2. Take away 2 is 0. 2 times 2 is 4. Take away 2 is 2. Once we've got that, we can actually draw the graph or plot the points. So you can see that x is minus 2, y is minus 6. So if we go to minus 2 across, and we see that minus 6 is off the graph. So we can't plot that one. So we move on to minus 1 and minus 4. Minus 1 and minus 4. That's it there. So it's just basically 1 to the left and 4 down. This one is 0, minus 2. So we're just going straight down to minus 2 here. And we just plot it like that. So once we've plotted it, we draw our line. Remember, the question has said, by drawing a suitable line in the grid opposite, solve the simultaneous equations. So to solve it, we have to find out the coordinates of where these lines cross. So we know what the x value would be, and we know what the y value would be. So from the graph, it was seen to be x is equal to 0.8 and y is equal to 0.4.